Thank you. All right, so I think that at this point, everybody here knows how Ubik works. Thanks to the presentation made by Mark. So thank you, Mark. Today I'm going to be talking about some of the limitations of Ubik. Some of the ideas that I'm going to be explaining here are very simple, but not so simple to explain. So if you guys cannot understand something here, just let me know, and I can take some few steps back and try again. And this is how this presentation is going to work. So I'm going to be talking about a few sectors of Ubik first. I'm not going to spend a long time talking about it because Mark did a very good job already. Then I'm going to be talking about some of the limitations of that specific section of Ubik. And I will finally be discussing what we have made over the past year to fix some of these problems or to at least improve this equation. And I would like to start talking about the election process. Oh, Mike, I forgot to ask you. Is that working? Okay. So the election process is very simple. So basically, every single site is going to try to be the Sine site, as Mark said, but only one site will be elected the Sine site. The site who's going to be elected the Sine site is the site with more votes, as simple as that. Usually, it's the site with the lower IP address. So let's take a look at this example here to see how it works. It's very simple. So every single site is going to ask for a vote. And the site with more votes will become the Sine site, which happens to be this one here. As you can see, this site only has 2 votes, but that's enough to become a Sine site because we only have 3 sites here. So now that we have a synchronization site, we can finally start the recovery process. So what's the idea here? Well, as Mark said, the synchronization site has to make sure that every single site has the most recent version of the database. To make it possible, the synchronization site is going to ask to every single site what version they have. And with that information, the Sine site is going to send a copy of the most recent version to everybody else. So again, let's look at this example here to see how that's going to work. So the Sine site is going to ask, what version do you have? In that specific case, this site here has the most recent version of the database. So the Sine site is going to request that version. All right, so now that the Sine site has the most recent version of the database, the Sine site has to send that version to everybody else. Okay, so what's the problem here? Well, as Mark said, during the recovery, we cannot have write transactions. Also, we cannot have read transactions. In other words, every single site involved will not be available during this phase, which can take some time, especially if the network is not working properly. Well, why we cannot have read transactions during this phase? Technically, we cannot have read transactions because we are replacing our database. But that's not how the current version of Ubik works anymore. Let's take a look on how Ubik works nowadays. So basically, the Sine site requests a copy of the most recent version of the database. But the Sine site does not replace the live database directly. Instead, the Sine site is going to store that version in a temporary file. And if everything worked as expected, then the Sine site can finally replace the live database by this temporary file. The same thing is going to happen with the other remote site. The Sine site is going to send a copy to that site. That site is going to store that copy in a temporary file. And if everything worked as expected, then we can finally replace the live database. So we have 2 possible scenarios here. In the first one site is sending a copy of the database to somebody else. If that's the case, we have no reason to prevent read transactions on that side. I'm not changing my database, so why I cannot have a read transaction here? In the second scenario, we are getting a new copy of the database. So eventually, we will be replacing our database by that copy, which means that we have to block read transactions here. But as I said before, we store that copy in a temporary file. So we only have to block read transactions when we replace the live database by that copy. And that's the first improvement we made here. We do not have to block read transactions during the recovery phase, only when we replace the live database by the temporary file. But one of the things that I have to say here is that when we replace our database by this temporary file, if we still have any read transaction running, we have to abort this read transaction. Why? Because that read transaction already read some data from the old version of the database. Now we have a new version of the database. So we came from a place where we could not have any read transaction at all to a place where we can have read transactions, but a few read transactions will have to be aborted. So now we have a Sine site, and every single site has the most recent version of the database. So we can finally have transactions. So, first of all, I would like to explain how read transaction works. Basically, one of the things that we have to understand is that read transactions happen much more frequently than write transactions. We only need write transactions for admin operations. So Ubik was designed to handle a high number of read transactions. And any server can handle a read transaction. So let's look at the sequence diagram to see how a read transaction works. So we have a few boxes here. The box with light blue is basically the Ubik layer. The dark blue is whatever is running on top of Ubik. So first of all, we have to create a new transaction. And we do that calling that function the new transaction.
What is printed in the light blue bars?
Ubik disk is visible.
Then we have to get a lock. We do that locally on the site that's handling that transaction. Then we can finally read some data. And as Mark said yesterday, Ubik, when he was talking about VLM hash, Ubik has a buffer, a cache, memory, with some pages of the database. So we try to find the data we are looking for in the buffer first. If we cannot find that data in the buffer, then we try to find it in the database. And we can finally give this data back to the application layer. And then we can start a transaction. So the read transaction is very simple. Now let's talk about the write transaction. So as I said before, write transactions do not happen as often as read transactions. You only need write transactions for admin operations. And with write transactions, all Ubik servers have to be involved. So let's look at the sequence diagram to see how write transaction works. So we have to create a transaction. We do that locally first, and then we create a new write transaction on the remote sites. Now we have a write transaction. We have to get a lock. And again, we have to get a lock locally first, and then we have to get a lock on the remote sites. Now we can finally write some data into the database. To do that, we update the buffer, the cache first. So let's say that we want to update these 3 pages here. So we update these pages first. We do the same thing on the remote sites. And then we can finally update the database with that data. And we do the same thing on the remote sites. Now we can finally release the logs. on the sync side and on the remote sides. So what's the problem here? Well, write transactions can be slow. Why? Because there is a communication cost. We have several sites involved. So if the network is not working properly, or something like that happens, that transaction is going to take a long time. And during that time, we cannot have any transaction at all. So basically, the whole cell is going to be blocked on that write transaction. Question is, how can we solve this problem? The answer is allowing read transactions even when we have write transactions. How can we do that? So now I'd like to start talking about write transactions. How can we solve that problem with write transactions? So first of all, we have to create a new transaction. Same thing here. We do that locally first, and then we do the same thing on the remote sites. Okay, now we have a transaction. Now we have to get a lock locally first, and then on the remote sites. And I'm going to ask you guys to ignore these two boxes for now. They do not make any sense right now. But I will come back to these boxes at the end of the sequence diagram. Same thing here. So now we can finally write some data into the database. And here's the secret behind brains during writes. Now, instead of one buffer, we have two buffers. The second buffer basically stores the old version of the page that's going to be changed. So before we change any page, we copy that page to the old version of the buffer first, and then we make the changes that we want to make. We copy these pages to the old version of the buffer, and then we change the pages. And we do the same thing on the remote sites. We copy the pages, then we change the pages. So now we have two versions of the buffer, okay? And we can finally update the database with that data. We do that locally first, and then we do the same thing on the remote sites. Now we'd like to come back to those two boxes that I was talking about. Basically, when a sync site has a write transaction, we have to check if we have any old data, if we still have any read transaction looking at old data. If that's true, we cannot proceed here. We cannot make any progress here. We have to wait until we do not have any read transaction looking at the old version of the buffer. Why? Because we only have one old version of the buffer, so we cannot have another write transaction now. So we have to check if we still have any read transaction looking at the old version of the buffer. If that's true, we have to wait here. If we do not have any read transaction looking at the old version of the buffer, we go through every single write transaction and we set a flag on these write transactions to make sure that from this point, these read transactions will looking for the pages that they want on the old version of the buffer first. And only if they cannot find these pages on the old version of the buffer, they will try to find these pages on the original buffer. And at the very end, when we try to release the lock on the remote sites, we check if we have any read transaction looking at the old version of the buffer. If we do not have any read transaction using the old version of the buffer, we can flush these pages. And we do the same thing locally. We check if we have any read transaction looking at the old version of the buffer. In this case, we do not have, so we can flush these pages. Basically, that's how write transaction works. You guys have any question? As I said, it's not very simple to explain, but I can try again if you want. No?
So when we start a transaction, do we have to declare what pages we are going to use at the very start, or is it just sort of a container object that we will record things in along the way?
You mean a write transaction or a read transaction?
A read transaction.
Okay, I'm going to talk about the read transaction now. Okay, so with read transactions, we have to create a new transaction. Then we have to get a lock. But we actually do not get any lock here. But we still use this function to check if we have a write transaction. If we have a write transaction, we set a flag saying that from this point, we're going to read any data from the old version of the buffer first. So in that specific case, let's pretend that we have a write transaction happening right now, which means that this read transaction is going to give preference to the old version of the buffer. So we have two pages that are dirty here. This read transaction is going to try to read the first 3 pages. So try to get, we can find these pages on the version of the buffer first. And then the last one cannot find here, which means that the write transaction that's happening right now did not change that page. So we can get it from the original version of the buffer. And of course, if we cannot find these pages in the buffer, we cannot always find these pages in the database. And we can finally give this data back to the application layer. So again, let's pretend that the write transaction that was running finished. Okay. So the same thing is going to happen here. This read transaction is going to check if we have a write transaction, which is not true anymore. And this read transaction is going to check if we still have any read transaction looking at the old version of the buffer. If that's true, we cannot flush these pages. But if that's true, which is true in that specific case, we can flush these pages. That's what we do here. Did I answer your question?
I think so.
Okay.
Well, you asked specifically if we have to pre-declare what ranges or what pages we're reading, but we do not. Right, we do that processing like as we do.
Yeah. Still, be careful about what we're accessing. So I guess this assumes that your write transaction is not going to attempt to modify more pages than you have space in your buffer as a whole.
Yes, but I think that was actually already true before this, because we store all the dirty data in the buffers, and we only write it to disk during commit.
Yeah.
Okay, so with these changes, we can have write transactions even when we have read transactions. And we can have read transactions when we have write transactions. That's one of the improvements that we have made. We still have some limitations here. First one is that we cannot have multiple write transactions running at the same time. But that's not, as Mark said, this limitation is a Ubik limitation. For simplification reasons, we cannot have more than write transaction happening at the same time. The second limitation is that our write transactions are blocked if we still have any read transaction looking at the old data, which I don't think is a big deal, because read transactions can finish very quickly. But yeah, I had to mention that.
So when you're looking at the old data, that's like old data from the previous write transaction. So like I have one write transaction called X,
Right.
And I got some read transactions going that are reading at the data from before X.
Yeah, like X minus 1.
Yeah. And so then I try and do a new write transaction X plus 1, what's being blocked. So X plus 1 is being blocked from writing if people are still looking at X minus 1, right?
Yes.
Not looking at X.
And that could be, like you could change it so instead of, like in Marcio's examples, we have exactly 2 copies. Like we have the old copy and the current like dirty copy.
Right.
It could change it to have n copies. You could have as many as you want.
Sure.
But obviously that's more complicated.
Yeah.
And like you said, there's not much motivation because read transactions go by very fast. They don't block on anything.
That's right. So yeah, the patches can be found on Gary. So far, I discussed two possible solutions to some problems from Ubik. First one is called grades the recovery. That one was made by me. I just pushed a few patches together today. The second one is called grades 3 from it, and it was made by Andrew. And it's also on Gary, if you guys want to take a look at that. Okay, so now I'm going to be talking about some of the other fixes that we have made for Ubik over the past year. So we have made several fixes, so I'm not going to be talking about every single fix we made. I'm going to be talking about only two of them, which for me are the most important fixes that we have made for Ubik. So the first one is called avoiding sites that did not vote for sync. So basically, every time that a remote site receives a request from the sync site to create a new transaction, this remote site is going to check if he gave his vote to the sync site that is requesting that transaction. If the answer is yes, then a new transaction is going to be created. If the answer is no, then that request is going to be refused. And every time that a sync site has a request refused, the sync site thinks that the remote site that refused the request is not working. And as a result of that, the sync site will not contact that remote site for a few seconds. Yeah, so to explain this fix, let's look at this specific scenario here, okay? So, where's the animation? Okay, so in that specific case, we have three sites, and for some reason, one of them is not reachable, it's not working. But that's not a problem, because we still have two sites, which is enough to elect a new sync site. So we have an election here, and the first site has enough votes to become the sync site. All right, so now we have a sync site. We can have as many read transactions, as many write transactions as we want. And let's pretend that for some reason, the network is fixed, and this guy is back. So what's going to happen here? The sync site is going to send a copy of the most recent version of the database to that guy. Why? Because that guy missed a few write transactions. So his database is not up to date. Okay. But this site, the problem here is that this site just came back. He didn't have the chance to get a request for vote from the sync site. And as a result of that, he did not vote for the sync site yet. Now let's pretend that we have a write transaction. The sync site is going to create a write transaction on the remote sites. But remember, this guy here did not vote for the sync site yet. So that request is not going to work on that site. The transaction is going to fail. And as I said before, since the transaction did not work here, the sync site is going to think that this guy is not working. The sync site is not going to talk to that guy for a few seconds. And as a result of that, the sync site is not going to request a vote from that site. But of course, as Mark said, a few seconds later, the recovery thread is going to check if that guy is alive, if he's back. And he's back. Actually, he's not back. He was always there. So the sync site, we realize that that site is actually working. The sync site, again, is going to send a new copy of the database to that guy. But again, this site still didn't have a chance to vote for the sync site. Now let's pretend that we have a new write transaction. What's going to happen? The same problem again. The transaction is not going to work on that site. So in a cell width very frequent write transactions, this cycle will repeat basically forever. As a result of that, the Sine side is going to be sending a copy of the database to that guy all the time. And also, bottom will only have 2 sites, which means that if we lose one more site, we will not have bottom anymore. So what's the solution to that problem? Actually, the solution is very simple. We just have to avoid the remote site that just came back until that site had the chance to vote for the Sine site. So if we have, for example, right, this guy just came back, but we have a new write transaction here, we do not try to talk to this guy. Why? Because he didn't vote for the Sine site yet. We just avoid this guy. And now the Sine site has finally had the chance to request a vote from that guy. That guy's going to say yes. The Sine site's going to send the most recent version of the database to that guy. And now we can finally have write transactions on both sides. So that's one of the solutions that we have made for Ubik. It's kind of simple. Any questions about this?
Well, just a comment on, I think we kind of skimmed over this, the check that the site does to see that when a write transaction comes in, it checks to see if it's coming from the Sine site that it voted for, right?
Mm-hmm.
Yeah, so that, like another way would be maybe looking at that and seeing like, you know, can't we just get rid of that check or something? But I just wanted to note that that check is important because write transactions can only come from the Sine site. So the reason that check is there is so if the servers are misconfigured or confused about who the Sine site is,
Yeah.
you don't have somebody besides the Sine site trying to create transactions. So
Right.
there's a good reason why that check is there.
Right.
Yeah, and I guess another comment is that we're sort of trying to not do things that we know in advance are going to fail.
Yeah.
Because like we know what the correct behavior of the Sine site or the clone that just came back is going to be. We know it's going to reject us, and so we don't even have to try it.
All right, so the only fix that I would like to talk about, which is the last one, is this one, update epoch as soon as Sine sites are active. So before I talk about this problem and the solution that we had for that, I would like to define epoch first. So basically, epoch is a global variable stored by the Sine site. And the Sine site uses this epoch to identify the transactions created during his mandate. So, as I said, the Sine site used that global to differentiate transactions created by the current Sine site to the transactions created by other Sine sites in the past. So basically, every time that the Sine site sends a beacon packet to the remote sites, the Sine site takes advantage of this packet to send this epoch. Basically, the epoch represents the time when that Sine site was elected. So he sends, along with the beacon packet, his epoch. And the remote site uses this epoch to check if it has any write transaction with an epoch different than that epoch. And if that's true, this means that this transaction was created by another Sine site in the past and must be aborted. Okay, so as I said, this epoch represents the time when the Sine site was elected the Sine site. But for some reason, that's not how Ubik used it to work. For some reason, Ubik used it to update that global only at the very end of the first write transaction. So let's see how Ubik used it to work. We have a new Sine site elected, and we do not update the epoch immediately. So now, at the very end of the first write transaction, we finally update that epoch to the current time. So what's the problem with that? So let's look at this scenario to see how something like that can be a problem. So the first site is aligned with the Sine site, but we did not update the epoch yet. All right. Now we have a write transaction. And for some reason, this write transaction does not work. We could not finish this write transaction, which means that at this point, this site has a write transaction that did not finish, and this site has also a write transaction that did not finish yet. And of course, the epoch of this transaction is going to be equal to 0 because this site was selected Sine site for the first time and didn't have the chance to finish this write transaction and update this epoch. So we have a write transaction here that did not finish with an epoch equal to 0, and we have a write transaction here that did not finish with an epoch equal to 0. Now let's say that for some reason we lose quorum and we have a new election. Now a new site that was never elected the Sine site before is elected the Sine site. Then again, his epoch will also be equal to 0. Why? Because he was never elected the Sine site. And this epoch will only be updated at the very end of the first write transaction. What's the problem here? We still have a write transaction here from the last mandate that was not aborted. So this site should be able to identify that write transaction from the last quorum mandate and abort it. How do we do that? We compare the epoch of the current Sine site with the epoch of the transaction we have here. If they are different, we know that the transaction that we have here is from the last mandate and must be aborted. But in that specific case, the epoch of the transaction that we have here is also equal to 0, which is equal to the epoch of the new Sine site. And as a result of that, that transaction is not going to be aborted on the remote side. So what's going to happen? This side is going to be blocked. Why? Because we have a write transaction here. And we cannot abort this write transaction. So basically, that remote side is not going to be working. We cannot create any write transaction on that side. And again, to fix this problem, the solution is actually very simple. We just have to update the epoch as soon as the Sine site is elected the Sine site, instead of at the end of the very first write transaction. So we have an election here, the site was elected the Sine site, and we immediately update the epoch on that site. That's how we fix this problem. So yeah, we made more fixes for Ubik over the past year. I'm only talking about 2 of the most important fixes that we have made for Ubik. But I know that Mark was talking about one of the fixes that I have made to prevent clone sites to become the Sine site. But that solution is actually very simple. I just had to make sure that the clone site does not request votes from the other sites. So that's pretty much it. So I don't know. It's a very simple solution. But if you guys want to talk about it, I can do that. But yeah, any question?
Do you have any questions for Marcio?
Oh, there's just one thing I wanted to clarify. I don't think anybody noticed this, but very early on in the presentation, you mentioned an example where we're running an election, and you say, like, we have 3 sites, and the Sine site gets 2 votes, which is a majority, so it's able to become, or sorry, it's running for Sine site. It gets 2 votes, so it's able to become the Sine site because it gets a majority of votes. In Mark's presentation, he was using the other notation for votes, or the other way to talk about votes, where, you know, in the code we count like 1 vote is equal to like 2.
Yeah.
Like 2. So in your example, a site needs 2 votes in order to like get a majority, and the lowest IP gets an extra half vote. But in the code, the way that that's represented, like, since the votes are stored as integers, so a half vote is equal to 1 and a full vote is equal to 2. So I'm just clarifying that in Mark's description of the voting process, like he said, each site gets 2 votes, and then the lowest site gets an extra 1 vote. So I don't think anybody noticed it, but it's confusing when you look at that because there's two different ways to talk about votes in different units.
Yeah, I was trying to provide a very high level about how it works. But yeah, if you look at the code, is what Mark said.
Yeah, I'm not sure which way like the paper is referred to. Either way is valid. It's just what units you're using, either whole votes or half votes.
Okay, thank you.
Anyone else have a question for Marcio?
Sure, I have a question. So when you allow reads during recovery, is there a limit on how old the database can be on the one that's out of date?
Yeah, we already allow reads. With the current version of Ubik, we already can read the old version of the database. So we are not changing that.
But no, I don't think there's a limit on how old it can be. It just needs to be a valid database. Like we don't let you read an empty database or something like that.
Any other questions for Marcio? Okay, thank you, Marcio.
Thank you.